Hello, welcome to this video. I'm Professor Tuta. In this video, physics, we'll be looking at work, energy, and power. But first, we need to look at work. Now, know that whenever you are doing something, there is a force or power which you apply in order to accomplish a task that you are doing. Now, what is work? Work is the product of force and distance in the direction of the force. So we are saying work is equal to force times distance. What we mean by this is, for work to be done, let's say this is a box and someone is pushing it, there must be a force, all right? A distance, let's say maybe from there to there must be there in meters. So you can see that the force is parallel to the distance, and that is only when work is done at this point. But if a force is going that direction and distance is going this direction, there is no work. Now we know that the units for force are newtons and the units for distance are meters. Therefore, when we say F times D, it's the same thing we're saying Newton times meter. Therefore, the units for work is just Newton per meter. Now, or know that a Newton per meter is the same as a joule, right? Therefore, you can also say just the symbol J for a joule. So let's give an example. All right? Let's say this is a box. It's on the floor and someone is pushing it with a force of 200 newtons, and the distance from there, it has moved, it's maybe, let's say, 4 meters. Calculate work done. Now the force, you know that work is equal to force times distance. The force is 200 newtons times the distance moved is 4 meters. Take note, distance should always be in meters. If you've been given distance in centimeters, make sure you convert into meters. We know that 100 centimeters is equal to 1 meter. Use this conversion to convert centimeters to meters. Now this will give us 800 Newton meter or 800 joules. All right, we have this example. This is a person. The person has lifted this box of 20 kg mass. Now this box was on the floor here, shown by these dotted box lines. So it was here, then it has been lifted up there through a distance of 8 meters. What is the work done? If you take gravity, it will be 10 Newton per kg. We know that work done is equal to force times what? Distance. Now force must be in what? In newtons. Now what we have here is mass. By now we know that force is equal to mass times what? Gravity. It's the same as when we say weight is equal to mass times gravity. These are just the same. So to find force in this case, we say since force is equal to mass times gravity times what? Distance. So mass is 220, gravity is 10 there, distance is 8. So we're having 200 times what? 8. That will give you 1,600 Newton meter or 1,600 joules as work done. Okay, let's look at this last example. We have a book here. The book is on top of the table, and the table is 30 centimeters tall, and the book is 2 kg. That's the mass. Taking G to be 10 Newton per kg, calculate the work done on the book. Now work done is equal to force times what? Distance. When we have mass, force must be mass times gravity times what? Distance. Now distance, the distance given here is 30 centimeters. Therefore this must be converted to meters. All right, now we know that 1 meter is equal to 100 centimeters. So if we have 30 centimeters here, how many meters are we having? So x will be equal to 30 centimeters divided by what? 100 centimeters. So x is equal to 0.3 meters. Mass is 2, gravity is 10, distance is 0.3. So we have 2 times 10 times 0.3, you get 3. 2 times 3, you get 6 Newton meter, or 6 joules. So thank you so much for watching. I'll see you in the next video.